Hi everyone, this is AKD SIR in the channel Classes with ILR. So in continuation with the laws of chemical combination, our today's topic is law of multiple proportion. Now what this law of multiple proportion says? It states that if two elements combine together in more than one proportion by mass to form several compounds, then the mass of one of these elements which combine with a fixed mass of the other are in the ratio of simple whole numbers. This is the law, To some extent, it's a bookish law, So let us explain it. So for example, sulfur combines with oxygen to form two oxides, namely sulfur dioxide and sulfur trioxide. Now according to this law, the mass of oxygen that should combine with a fixed weight of sulfur, say 32 parts. Why 32 parts? Because the RAM, relative atomic mass of sulfur, is 32. Should be in a simple whole number ratio to each other. Actually, in SO2 and SO3, that is sulfur dioxide and sulfur trioxide, the mass of oxygen that combine with 32 parts, that is the atomic mass of sulfur, are in the ratio of 32:48, or it is simplified as 2:3. Similarly, carbon combines with oxygen to form carbon monoxide, that is CO, and carbon dioxide, that is CO2. The mass of oxygen that combine with 12 parts, that is the RAM of carbon, by mass of carbon in two compounds are the respective ratio of 16:32, or it is simply 1:2. So this is the basic tenet of the law. Okay? Now let us take one example or illustrative question. Elements of A and B combine to form three different compounds. This is given, 0.3 gram of A plus 0.4 gram of B. They chemically combine to form 0.7 gram of the compound X. Another data, 18.0 gram of A plus 48.0 gram of B, that chemically combines to form 66.0 gram of compound Y. And 40.0 gram of A plus 159.99 gram of B turns into 199.99 gram of compound Z. Now you have to show that the data given, that is the above data that are given, illustrates the law of multiple proportion. Now let us answer it. Mass of B that combine with 1.0 gram of A in the compound X, Y and Z are respectively 0.4 upon 0.3, that amounts to 1.33, 48.0 by 18.0, that amounts to 2.66, and 159.99 upon 40.0, that amounts to nearly 4. So ratio being 1.33 is to 2.66 is to 4.00. You divide all the received, the minimum number 1.33, and that comes down to 1:2:3, that which is a simple ratio. And this illustrates the law. Now let us come to next question. This question was set in the IIT entrance test 1973, a subjective question. Carbon combines with hydrogen to form three compounds A, B and C. the percentage of hydrogen in A, B and C, mind you percentage, is 25, 14.3 and 7.7 respectively. Now there are two questions. One is find the empirical formula of the compounds, and number two, which law of chemical combination does this example illustrate and how? So this was the question in the IIT entrance test 1973 that we just said. Now let us answer it. You know, empirical formula, we first form a table, the element, the carbon and hydrogen. Compound A, the percentage was given, 75%, okay, and 25%. 14.3% is the hydrogen, naturally the carbon is 85.7. You deduct 14.3 from 100 and your carbon becomes 85.7. Likewise, in the compound C, 7.7% is hydrogen, so naturally the carbon is 92.3%. So the atomic ratio will be, you have to divide the respective percentages with the relative atomic mass of the element. So 75 by 12 is to 25 by 1, that becomes 6.25 is to 25, that equals to 1 is to 4. So the empirical formula is CH4. In the compound B, it is 85.7 upon 12 is to 14.3 upon 1, that equals to 7.14 is to 14.3. This is roughly 1 is to 2. And here in the last case of the compound C, it is 7.7 is to 7.7, and that amounts to 1 is to 1. So the empirical formula is CH. So in the compound A, the empirical formula is CH4, the compound B, the empirical formula is CH2, and in the compound C, it is CH. Okay, so the first part of the question is answered. The empirical formula of respectively A, B and C that we have found out. Which law it illustrates? Now you see, since the number of hydrogen atoms, or you can say the mass of hydrogen, that combines with one atom or 12 parts by mass of carbon, in the three cases that bear a simple ratio of 4 is to 2 is to 1. And this is a simple ratio. And that was the basic tenet of the law of multiple proportion. So this illustrates the law of multiple proportion, and here we answer the question. And the last illustrative example for today's video session is this question. Copper gives two oxides on heating 1 gram each in hydrogen, that is, it will be reduced. We get 0.888 gram and 0.798 gram of metal. Metal means the copper. So that the results are in agreement with the law of multiple proportion. And now let us take on to the last example of today's video session with regard to this law of multiple proportion. And this illustrative example is as follows. Copper gives two oxides on heating 1 gram each in hydrogen. We get 0.888 gram and 0.798 gram of metal. Metal means the copper. So that the results are in agreement with the law of multiple proportion. And that is your question. Now let's answer it. Given in 1 gram of copper oxide of the first kind, the copper present is 0.888 gram. So definitely the rest is oxygen. Therefore, oxygen present is, we subtract this 0.888 gram from 1 gram. That is, that will be 0.112 gram of oxygen. In the second kind, the copper present in 1 gram of the copper oxide, that equals to 0.798 gram. Therefore, the rest is oxygen. Therefore, the oxygen present is 1 minus 0.798. that equals to 0.202 gram. Therefore, from the workout we can see that 1 gram of oxygen in the first combines with 0.888 by 0.112, that equals to 7.928 gram of copper. And 1 gram of oxygen, the second kind, that is the second copper oxide, combines with 0.798 over 0.202, that equals to 3.95 grams of copper. Therefore, the ratio of copper present in the two cases, that equals to 7.928 is to 3.95, and that amounts to 2:1, and that which is a simple ratio. And this illustrates the law of multiple proportion. Now, before I end this session, I have a request to the listeners that if you people are liking the contents of my channel, I will request your pleasure to subscribe, to share, or to like my channel. Thank you all.